We are going to discuss a brief notes of probability which will be very helpful in your 12th exam, cbse as well as JEE Mains or advanced. First of all, we will discuss about experiment. An operation which results in well-defined outcomes is called an experiment. Okay, any operation which will give you a well-defined outcomes is called an experiment, like throwing a dice, taking a card from the pack of 52 cards, or drawing a ball from a bag containing various color balls, etc. Now, random experiment. An experiment in which the outcomes may not be the same, even if the experiment is performed in an identical condition, is called a random experiment. Basically, it is whose outcome is not predicted. That type of experiment is called random experiment or unbiased experiment. Now, come to the sample space. Total number of all possible outcomes of a random experiment is called sample space. Means throwing a two coins. What are the possible outcomes? HH, TT, HT, and TH. Okay, so all these four events will be called the sample space together. Now, event. What do you mean by event? A subset of the sample space associated with the random experiment is called an event or a case. So clear means one subset. Suppose two heads after throwing a two coins. Two head getting a two head is an example of one event. Suppose in tossing a coin, getting either head or tail is an event. Okay, in that case, TH or HT will be the two event in your favor. So this is in diagram I have written. Random experiment, throwing a die. Sample space is all possible outcomes. So all possible outcomes are 1, 2, 3, 4, 5 and 6. And suppose event, outcomes of interest, that is the multiple of 2. So these are 2, 4 and 6. Clear event? Come to the next. Equally likely events. The given events are said to be equally likely if none of them is expected to occur in preference to the other. Means, suppose you are throwing an unbiased dice, so all the six spaces, either 1, 2, 3, 4, 5, or 6, may appear on the equal probability basis. Okay, clear? Equally likely events means if one will happen, it will have the same probability if the other event will happen. Those type of events are called equally likely events. Now, mutually exclusive events. A set of events is said to be mutually exclusive if the happening of one excludes the happening of the other. Basically, we used to say exclusively for you means none other than you can say. So that is the case with the mutually exclusive events. If A and B are mutually exclusive, then A intersection B will be 5, means nothing will be common. If A happens, B will not happen, so no common. In throwing a die, all the six spaces number 1 to 6 are mutually exclusive. Since any one of these spaces comes, then possibility of other in the same trial is ruled out. Clear? Means if 2 appears, then possibility of 1, 3, 4, 5 and 6 will not happen. So those type of experiments are called mutually exclusive. So here also I have written the same thing. Mutually exclusive events are two or more events that cannot occur at the same time. For example, getting heads and tails in a coin toss or rolling a 2 and a 3 on a die. Okay. If two events are mutually exclusive, then P A or B means P A union B will be equal to probability of A plus probability of B. Generally, its formula is PA plus PB minus PA intersection B. But intersection is fine in case of mutually exclusive, so its probability will be 0. So only this will happen. PA or B will be PA plus PB. Now, one more example I have given you for you to understand. Equally likely events means all events have the same probability. Means suppose two events are there, E1 and E2, where E1 is getting a head and E2 is getting a tail. So both probability will be same. That is the definition of equally likely events. Mutually exclusive events means cannot do both simultaneously. Means E1 and E2 probability will be 0 because their intersection is 5. Exhaustive events, in the next slide we will learn, covers all possible outcomes. So probability of E1 or E2 means E1 union E2 and will be equal to 1. This is also the condition. Exhaustive events means their union will give you the sample space, and probability of sample space will be 1. Why? Because the favorable event is sample space and total number of event is also sample space for that reason. Right? More clear it will be. Exhaustive events. A set of events is said to be exhaustive if the performance of the experiment always results in the occurrence of at least one of them. Understood? Means set of events is said to be exhaustive if the performance of the experiment always results in occurrence of at least one of them. Means exhaustive events are those events which gives you when you do their union, it will give you the sample space. So at least one of them must be there in the S. Yes or no? Then only their union will give you S. Clear? This is the meaning of this line. And also, even E2 and dash dash En are mutually exclusive also. Means if one happens, then other will not happen. If even event happens, then E2 will not happen, or E3 will not happen, or En will not happen. Okay? This is the meaning of exhaustive events. Okay. Now, in throwing off for 2 dice, the exhaustive number of cases is 6 into 6, that is 36. Now, since any of the number from 1 to 6 on the first die can be associated with any of the 6 numbers on the another die. So this is the meaning of exhaustive events. And exhaustive events, all the 36 events, if you choose any one event, that will must belong to this 36 group of 36 events. Okay, this is the meaning of this slide, that performance of the experiment always results in occurrence of at least one of them. Means so many events are there, they are called exhaustive if E1, E2 and En union will give you S, and all the E1, E2, En will belong to this S. This is the meaning. And mutually exclusive, that you have understood. Now come to the complement. This you know in previous classes also. Suppose this is a universal set U. This is A. Then complement of A is this part, the white part. Okay, means which is not in A. So let A be an event in a sample space S. Then the complement of A is the set of all sample points of the space other than the sample point in A, and is denoted by A dash or AC. And A dash means those values which will belong to S but does not belong to A. This is clear? Now come to the next. Probability of an event. Some properties are there for the probability of event that also you know already, because we are interested in discussing this conditional probability. First of all, just have a recall. If a trial results in n exhaustive, mutually exclusive, and equally likely cases, and m of them are favorable to the happening of an event, then the probability of happening of A is given by, favorable number of event by total number of event, that is m upon n. And it is lying between 0 and 1, where 0 is for impossible event and 1 is for sure event. Otherwise, PA will be a fraction between 0 and 1. So this is impossible event is 0 and certain event is 1. Now P, A union A dash is PS. Just now we have understood. A union A dash will give you probability of the sample space, and A intersection A dash will give you probability of the null set, that is 0. Probability of A dash dash is nothing but probability of the event A itself. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. Okay, now come to this. This is important. Conditional probability. In case of conditional probability, you have two events. Okay, one will be the event which already has been happened, and another will be event you have to find out what is the probability of the second event when first event already have occurred. Okay, this is the meaning of this conditional probability. Means there is a condition, means something has happened, then based on that condition you have to find the probability of upcoming event. So let us see. Let E and F be the two events associated with the same sample space of a random experiment. Then probability of occurrence of event E when the event F has already occurred is called a conditional probability of E over F, or given F, and is denoted by E over F or E given F. And its formula is E over F probability is probability of E intersection F divided by probability of F, because probability of F event has already occurred, so that will make your total number of outcomes, and E intersection F means event E and F intersection, that probability will give you, when divided by PF, will give you the probability of E when F has already occurred, means conditional probability. More insight we will see in the next slide. This is the diagram, conditional probability. So A and B are the two events, something is common there also. So conditional probability formula is, just now I have written, probability of A given B is probability of A intersection B divided by probability of B. So this B, the when you recognize, how will you recognize whether it's condition or conditional probability? One sentence is already written that B has already occurred, or B has seen, B has known, B has visited. Okay, these type of words are given in the question. So you will understand that this is a question of conditional probability. Now come to the next. Suppose we want to find out the relation between the probability of A given B and probability of B given A. So how does it happen? See, both the diagrams are same, only thing the explanation is different. Let us see. Probability of A given B. A given B has occurred. So what happened in this case? If B has already occurred, then our sample space must be somewhere within B. Is that clear? Similarly here, probability of B given A means if A has already occurred, then our sample space must be somewhere within this A part. Okay. Similarly, now A can occur only within sample space of B. For this, only this part we will take, which will be common. So here it is given, the common part. Therefore, probability of A given B is the ratio of the red space divided by the green space. This is your ratio of the red space divided by the green space. Okay. Now here, now B can occur only when within the sample space A. This one. Okay. So probability of B by A is the ratio of red space divided by the white space, isn't it? This is the red, the common part will be the same, and it will divided by the A, which is in white in color originally. So we are getting P B given A as PA intersection B by PA, and PA given B is PA intersection B by PB. So you can see this and this point are same. So we can write that PA given B into PB will be equal to PB given A into P. This relation makes the base of the Bayes theorem in the probability. So we'll see in the next slide. This is okay, PA by B. Now it becomes P B over A into P of A divided by P of B. And this is the basic theory behind the Bayes theorem, which we will learn in the next slide. Now, first of all, we'll discuss few properties of conditional properties. It is very unclear if E and F are two events in a sample space S, and G is an event of S which has already occurred, such that P of G is not zero, means non-zero property, because when you divide something by zero, it is not defined. Okay, undefined case will happen. So PG is not zero. Then probability of E union F over G will be probability of E over G plus probability of F over G minus probability of E intersection F over G, and PG not equal to 0. So this formula is same as E union F, which gives E F minus E intersection F. Only thing is divided by G, so everywhere there will be a division by G. Conditional probability case. Similarly, P E union F over G is equal to PE over G plus PF over G if E and F are disjoint events. And in case of disjoint events, this becomes 0. So this term is get cancelled over here. Similarly, probability of F dash over G will be 1 minus probability of F over G. That you know, complement formula, F dash is 1 minus F. Probability of S over E will be probability of E over E, that is 1. Why this you can understand like this. Probability of S over E means probability of S intersection E divided by probability of E. Now S intersection E means what? Sample space and one event intersection. Will we give you E only? So E over E, that is one. Now few more formulas are there for the multiplication theorem in probability. Let us see. If E and F are two events associated with sample spaces, then the probability of simultaneous occurrence of the event E and F is like this. Probability of E over F. Just now we have discussed the formula. E intersection F by PF. Probability of F over E. F intersection E divided by P. So P intersection F can be written in two ways. P into P F over E, or P into F into P E over F, where PF and PE both are non-zeros. Okay, non-zero. Why I am saying? Because when you make it non-zero, then you will see the defined. This is E. Okay. Now, otherwise it will become undefined. This result is known as multiplication rule of probability in case of dependent. Dependent means conditional probability case. This is the multiplication theorem. Now, when it is independent, then this intersection will give you directly the product of independent event probabilities, that is P into PF. Okay. In case of disjoint, E intersection F becomes phi, so this probability also becomes 0. And mutually exclusive and disjoint are the same meaning. Okay. Now, independent and mutually exclusive do not have the same meaning. Independent event and mutually exclusive as well as disjoint events, means these two are same. So mutually exclusive and independent event are not same. Now, disjoint events are dependent. Disjoint events are dependent. Okay, not independent unless at least one event has zero probability. Now, why I am saying like that? See, disjoint events in the case E intersection F becomes 5, so probability of E intersection F becomes 0. Now, why I am saying dependent? Because they will be independent only if their product becomes P into PF. Now, P into PF product will give you 0 only when either this or both are 0. Okay, so that is why I am saying that disjoint events are dependent unless at least one event has 0 probability. Okay, clear? Means not independent. Disjoint events are not independent. They are dependent unless and until at least one event has 0 probability. Now come to this. Joint event can be either dependent or independent. Okay, means when the something is common, E intersection F has some non-zero value, then that type of event can be dependent as well as independent, depending upon the situation, whether its probability gives P into PF in case independent, and if its probability can be found out like this formula, then it will become dependent case. Okay, now come to the next. Now, Bayes theorem I have seen. Bayes theorem. In Bayes theorem, there is a sample space. Out of that, there is a partition which are mutually exclusive. Means nothing is common, like B1, then B2, then this is your B3, and this is your B4. So among B1, B2, B3 and B4, nothing is common. So they are mutually exclusive events. But when you join B1, B2, B3 and B4, you will get this whole sample space over here, the rectangular portion. Also, there is an event A, which we say that it has already occurred. Okay. And depending upon that, we will see the details about the Bayes theorem. Let us see. First of all, understand partition of sample space. That in that example, I have said B1, B2, B3 and B4. So a set of events E1, E2, E3 and En is said to be represent a partition of the sample spaces if it is satisfying the following conditions. Number one, their intersection is phi. Just now I have told you B1, B2, B3, B4 are the four partitions and their intersection was phi. And their union will give you the sample space. Means B1 union B2 union B3 union B4 gives sample space. And their probability is also greater than 0, okay? Non-zero, which is lying between 0 and 1. Now, one more theorem comes before Bayes' theorem extension. We have to discuss about the theorem of total probability. Just now, let us see. Very easy. Let events E1, E2, En form a partition of the sample space S. From this only it is clear. If A is an event associated with the sample space, just now before in the previous example I have shown you, okay, then theorem of total probability says, okay, once again I have drawn another example that this is your whole sample space, and here E1, E2, E3 and En are the partitions which are mutually exclusive, but their union will give you S. And there is another event called A which has already happened. In that case, what is the total theorem of total probability? So let us see. Is useful to find the probability of the happening of an event from different partitions of the sample space. For a sample space divided into n partitions such that their union gives S, the probability of happening of the event A from the different partitions is, okay, means A is occupied by here also, some portion is occupied by here and here. So when this is the case, in that case what is the total probability of A? How will you calculate? Means when E1 is given, E2 is given, E3 is given, En is given, in that case what will be the probability, okay, of this A event? So let us see. One formula you know, probability of A intersection E1. In case of conditional probabilities, you can write probability of A upon E1 into probability of E1. Okay. If you have confusion in that, you can understand like this. This can be written as probability of A intersection E1 upon probability of E1. This will come within the division sign and we can then multiply. So this you basic thing you know. So can you understand that A intersection even from this portion, what you will get? This triangular portion. If you do E2 intersection A, then this area you will get. If you do E3 intersection E, you will get this. If you do and so on, E4 and suppose here En this portion. So together the intersection, all the intersection portions when added together, you will get the probability of A. Yes or no? This is the theorem of total probability. So PA will be nothing but this is the portion of PA intersection E1, first portion. This is the portion of this A intersection E2, second portion. Okay, and in terms of conditional probability, we will write like this. PA intersection E1 can be written as PE1 into PA upon E1 plus PA2 PA upon E2 means given E2 plus dash as PEN into PA given E. Clear? This is the theorem of total probability and this is very helpful in Bayes' theorem. Okay. It is written. Theorem of total probability is the foundation of the Bayes' theorem. Let us learn more about the application of the theorem of total probability. Now Bayes' theorem. Actually, in terms of statement, it is like that. In statistics and probability theory, the Bayes' theorem, also known as the Bayes' rule, is a mathematical formula used to determine the conditional probability of events. Essentially, the Bayes' theorem describes the probability of an event based on the prior knowledge of the conditions that might be relevant to the event. Okay, something has happened prior in priority. In that case, you have to find the remaining events, upcoming events probability. In that case, Bayes' theorem is being used. Now, Bayes' theorem is used to revise previously calculated probabilities based on the new information. Okay, means something is given and something new you have to calculate. Developed by Thomas Bayes in the 18th century. It is an extension of conditional probability. So that is why I have written over it. Probability of Bi given A is nothing but probability of Bi, this Bi into probability of A given Bi divided by P. Okay. Now, Bayes' theorem, when you have so many events, like previously I have taken that partitions as B1, B2, B3 or E1, E2, E3 and up to En. Same thing was there. So, in comparing with that case, probability of Bi over A means given A, will be written as according to this formula. PA given BI into PBI upon PA. And PA is nothing but the total probability theorem. So with this, the whole thing will be written like this. First of all, PA over B1 into PB1 plus PA over B2 into PB2 plus dash 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 PA over BK into PBA. Okay. If there is n partitions, then PA over BN into PBK will be there. Okay. Where BI is nothing but ith event of the K mutually exclusive and collectively exhaustive events, and A is the new event that might impact probability of happening of BI event. Okay, clear? Now, next video I will show you the problems related to the Bayes theorem. Okay, this is 30. Now come to this. There is one example I have written over here. Suppose x is a variable taking values 12, 13, 14, 15 and 16. Px is given like this: 0.27, 0.25, 0.18, 0.15, 0.15. Then we will multiply x into px and we will get like this data. And x square we will find by just squaring all these and multiply x square into px like this. Then a very important formula comes here: mean. In case of probability distribution, mean will be given by mu is the summation of x into px, that is this whole summation whatever you will get. So you have got 13.66 if you will add all these. Similarly, this is called variance, sigma square. Its formula is summation x square into px minus mu square. So x square into px here, this summation if you will add, you will get 188.56 and minus this 13.66 square. So sigma square is nothing but variance. And this is called standard deviation, which is the square root of variance. So whatever you have got over here, square root that, you will get the value as standard deviation. Why I have written this example before? Because by this you will learn better the next formula. See, random variable. A random variable is a real valued function, right, like x, which I have taken in the previous example, whose domain is the sample space of the random experiment. Generally, it is denoted by capital letter X. And probability distribution means variable is having different probabilities. The system in which the values of the random variables are given along with their corresponding probability is called probability distribution. So if x be a random variable, it can take n values, x1, x2, xn, and respective probabilities p1, p2, pn, where p1, all the sum of the p1, p2, p3, pn will be finally 1. Okay, so in that case, now Bernoulli trial. Okay, there is one more slide is there, so we'll relate to that. Before that, you understand Bernoulli trial. Trials of a random experiment are called Bernoulli trials if they satisfy the following conditions. There should be a finite number of trials. First condition. Any trial will be called Bernoulli trial if finite number of trials are there. Trials should be independent. Means one trial should not affect the trial of the another. Each trial has exactly two outcomes, success or failure. Okay, more than two outcomes doesn't come under the category of Bernoulli trial. The probability of success remains the same in each trial. Okay, means unbiased trial is there. Okay, so how it is important this trial you come in the here and in this portion. Okay, and before that, just now we have discussed now mean xi into pi, that is np. Okay, variance is sigma square, that is x square into pi minus mu square, that is called npq also. Standard deviation is sigma, that is square root of variance, that is square root of npq. This I was wanted to write there, but I have not written. I have written at the last. So please uh, bear with me. Now come to the binomial distribution. The probability distribution of numbers of successes in an experiment consisting of n Bernoulli trials obtained by the binomial expansion of p plus q power n. P and q are what? P is the of success probability and q is the failure probability, and n trials are there. So you know the binomial distribution. Binomial distribution is what? NC0 P power n into Q power 0. Then NC1 P power n minus 1 into Q power 1 and so on. Yes or no? So if x random variable take n values x1, x2, xn, then by binomial distribution probability of rth trial can be written as NCR into P power r into Q power n minus r. Okay, that you know. So n is the total number of trials, P is the probability of success in one trial, Q is the probability of failure in one trial, R is the number of success trial in an experiment in rth trial. Okay. Also P plus Q is 1 means probability of success and failure together will give you 1. Binomial distribution of number of x-axis. Now this is all about the probability, and thank you for listening me.